Finally, I have my while loop instead of a simple loop that says start at the first, while my index is not null, get the birthday, go to the next element. And what I've done is run this code for two scenarios. In fact, let's run this code for a couple of scenarios, and then we'll take a look at the timing aspect, the performance aspect of this. So I'm going to create my procedure, and then I'm going to run it. Now, first of all, let's just run it for show birthdays 2. So, because I'm passing in 2 for the second index, notice that my collection is densely filled 1 to 2, so first to last doesn't have any gaps in it. So when I show the birthdays, it says timings with second row, check exists. What you're seeing here are the timings. There were no errors that occurred, so I only see the timing reports, which are not very interesting right now. But the main thing is we don't see any no data found exceptions. Didn't try to look at an undefined element. Okay, now if I do it again, and I specify, let's say, 15 for my second row, then when I run this code, notice it now says, try to look at undefined element. So in the case where I didn't trap the exception and allow it to continue, which is right here, the first time it went from 1 to 2, because it was going from 1 to 15, it tried to touch the row that didn't exist, raise the exception, display the message. In all the other cases, I've handled the situation with either the exists operator or trapping the exception and continuing. So it didn't show me any message, and I didn't have an error. So that's the difference in behavior between having something that's densely filled and sequentially filled. With the 1 to 15, I got the message. In all these other cases, I was able to avoid getting a no data found exception. But let's talk about the optimal algorithms here, because as you can see, and as is almost always the case in programming, there are multiple ways to accomplish the same thing. I want to iterate through all the elements in my birthday list. I can go from first to last with exists. I can go from first to last trapping the exception. And I can use my while loop. And what you'll find is that the performance of these different approaches can vary greatly. For example, when I ran show birthdays with a second index value of 10 million, or sorry, of 1 million, so my first index value is 1, my second is 1 million, what you'll see is that you can pay a very significant performance price depending on how you write your loops. So first of all, let's go to the bottom. Using first and next, so my while loop, it took less than 1/100th of a second to perform my loop through those two elements, which is not surprising. It's just two elements. But notice with my trap, no data found each time. It took 1.7 seconds. Much, much faster. Well, sorry, much, much more time, much slower. And that's because what it did was go from 1 to 1 million. It did it 1,000,000 times. It iterated the loop 1,000,000 times and trapped the exception, raised and trapped the exception 1,000,000 times. And raising and trapping exceptions is quite slow in PL SQL. So 1.7 seconds to process that same, to run through the same data, that took me less than 1/100th of a second using my while loop. And notice check exists each time took 0.16 seconds. And what you see here is the overhead of calling the exists operator over and over again. Now 0.16 seconds over 1,000,000 iterations is not terribly slow, but still, it's a noticeable amount of overhead that's totally unnecessary. If you're iterating through a collection that is not sequentially or densely filled, you should always use the first and next or last and prior methods to navigate through the collection. Because then no matter how the data is distributed in your collection, whether it's densely packed together, whether it's very loosely defined in which you have a range of index values which are very large compared to the number of elements in your collection, you will still get the same good performance. So the bottom line for loops is use the while loop or simple loop whenever you have a non-densely filled or a sparsely filled collection. You can use the for loop, either going from first to last or 1 to count, depending for sequentially filled collections, depending on what the first value is. If it's 1, you can go from 1 to count. Otherwise, first and last. The final collection method that gives you information about a collection is the limit method. The V-array is a special type of collection in which it has a predefined or upper limit. So you can say when you declare the collection, this collection can have no more than 5 elements. And here's an example. So this V-array, or a variable based on this V-array type, can have no more than 5 elements defined in it. And if I want to find out what that limit is, I can call the limit method. So I declare my new type of collection. I declare a variable based on that collection type. I initialize it. We'll talk more about this under nested tables and V-arrays. And then I display the limit. And when I run this code, I see 5. So that's what the limit method does for us. Okay, let's finish up this lesson by talking about methods that change a collection. The most common would be the delete. Delete one or more rows from the collection. Extend adds rows to the end of a nested table or a V-array. And trim removes rows from a V-array or a nested table. So the delete method, you can delete one or more rows from an associative array or nested table using delete. You cannot use delete with V-arrays. In fact, you'll get a PLS 306 error, wrong number or types of arguments if you try to delete from a V-array. You can specify a range of values for your delete, so there are multiple formats for the delete operation. First, I can simply say .delete, so there's my method attached to my variable. .delete says get rid of everything in my collection. Empty it out. So the count after a delete like that is 0, always 0. I can specify a single element to be removed from my collection. In this case, I'm saying get rid of the end of the list, but I could specify any index value. And I can also specify a range of values. So get rid of everything between 1400 and 17,255. And if you do specify a range, these index values do not have to be defined. Anything between those two values will be erased. Let's take a look. So here what I'm going to do is declare a collection of records, another associative array. I'm going to populate my collection of records with a bulk collect query. That's bulk processing. I'm going to get rid of the first one. I'm going to get rid of everything between 7 and 20. Let's fix my typing there. Here's an example of deleting all the even rows. So go from 1 to the count in my collection. If the element exists at that location, and the mod of that index in 2 is equal to 0, delete that element, and then delete all the remaining rows. So let's try that out, see if I get any errors. So no errors, and it did all the individual delete operations. And if we try to delete from a V-array, we should see some very different behavior. So you cannot delete from a V-array. You can only trim off the end of a V-array. V-arrays are always densely filled. The delete operation, as you can see, can introduce gaps in my collection. Get rid of everything between 7 and 20. Get rid of just the even indexed, even elements. So by doing these kind of delete operations, you can introduce gaps between first and last. This is true for nested tables and associative arrays, but you cannot delete from within a V-array. You can make room for new elements with extend. Extend is only for use with V-arrays and nested tables. And what you're basically doing is telling Oracle to make room for n number of new elements at the end of the collection. And you can specify one at a time, or you can specify bulk extends, in which I could say, well, I know I'm going to need 10,000 rows, so let's extend 10,000. And you can also specify the value of the new element from an existing element. Let's take a look. So here's a nested table of employee records, and I'm going to initialize my nested table. We'll talk about initializing in a separate lesson. I'm going to make room for one element, so extend without any parameters. That means that there's now an element defined at index value 1. I can assign the last name, the first name, etc. If I want, I can do bulk extending, so extend 5 more rows. Now I've got a total of 6 elements defined in this collection. And I can even say, well, extend 10 and set all the element values to the same value found in index position 1. And after doing all of that, I should have, let's see, 10 plus 5 plus 1. I should have 16 elements defined. So what I'm going to do is iterate from 1 to the count and display the first and last names at each one of those locations. Let's try it out. Let's see what I get. In fact, let's do that again. Get rid of all that previous text. And what it shows me is that index value 1 has Engelbert Ellison as the employee name. From 2 to 6, no name at all. And from 7 to 16, Engelbert Ellison. So why did this happen? Why do we see this output? Well, at index position 1, I defined explicitly the last name and first name of that employee. I then extended 5. I did not provide a default element, so it automatically extended 5 records, but everything in the records are null, so the name is null. For the next 10, from 7 to 16, I specified use whatever value is in index position 1. So notice all the names for those records are set to the same. Now the following script, in the extend SQL script, there's a block of code here that demonstrates the performance advantages of extending in bulk rather than extending one at a time. So there's individual extends for 1 million iterations, or sorry, 10 million. Here's a 10 million extend all at once. And then also the alternatives in terms of extending and adding a value, or extending and then reference the previous value. And on 11.2, you see some significant differences in performance. So individual extend, 10 million extends 1.75 seconds. Bulk extend 0.06. So generally speaking, if you know you need to extend n number of rows, do it all at once versus incremental extensions. Trimming elements from end of a collection. This is available only with V-arrays and nested tables, and this is different from the trim function, which is a string function that trims characters leading or trailing on the string. You can trim one or multiple elements, get rid of the last element in my list, get rid of the last 10. And if you try to trim more than is in the collection, you'll get the subscript beyond count error. Trim is the only way to remove elements from a V-array. You cannot do a delete. Let's take a look. Okay, in my trim program, I have a collection of records. I populate all the collection from the employees table. I find out how many elements I have in my collection. Sorry, the last defined index value in my collection, which is the same as count in a V-array. Whoops, this is a table. Sorry, not a V-array. It's a nested table. So this shows me the number of rows defined in my collection, which is the same as the count of rows, since it's populated with a bulk collect. Then I'm going to trim a single element off the end, and I'll see what my new last value is. And when I trim off 10, we'll see what's left after that. Whoops. Okay, so last index first is 107. So the employees table has 107 rows in it. I'll prove it to you. It has 107 rows in it. So when I do a bulk collect, I've retrieved all the data from that collection, populated my collection, sorry, all the rows from the table, populated my collection, 107 rows. I trim once. The last is now 106. I trim 10 times more, and the last is 96. So it's pulling them off the end of the list. Is it faster to trim in bulk or individually? Same question as with the extend operation. What if I know that I'm going to be trimming a whole bunch at once, and I found again that trimming iteratively is slower than trimming in bulk. And depending on the number of elements you're trimming, it can make a big difference. 12 seconds to trim 100,000 times versus a single trim, 0.01 seconds. So again, if you know you're going to be trimming a lot, don't trim inside a loop, trim in a single operation. But in any case, for nested tables and V-arrays, it always is pulled off the end of the list. Whereas the delete operation, the delete method, gives you the flexibility to specify which index value you want removed. Drawing some conclusions. So methods in general make it much easier to work with collections. If you couldn't ask about the count, if you couldn't do deletes, if you couldn't navigate with first and last and next and prior, in other words, if your collection was a black box, an opaque structure, it would be very difficult to work with it. The collections really open up, the collection methods really open up collections, making them easy to work with, easy to understand their contents, easy to manipulate. But remember, when using the navigation methods, particularly when you need to iterate through the collection, make sure that you use the appropriate type of loop to iterate through the different elements. If your collection is densely filled, then you could use a numeric for loop, and if you know it's always going to be densely filled. If your collection might be sparse, it might have gaps between first and last, then you should always use a while loop or a simple loop. Next steps. If you haven't already done so, download the demo-zip script. Try out all the different files in this lesson. There are a lot of examples, and you should make sure that you understand exactly what's going on in each of those different scripts. And then watch the next webinar in the series, which is working with associative arrays, the most interesting, complex, and flexible of the different collection types.